All right, so my name is Kory Draughn. I'm the Chief Technologist for the iRODS Consortium, and this talk is going to be about irods4j, which is a brand new Java library that we've designed for irods4.3.2 and later. All right, so the motivation behind this is primarily that we encountered many challenges around maintaining jargon. So I think in the last year and a half, we took over the jargon project, officially took over the jargon project, which is, I think is about 5 or 6 repositories which make up jargon. This library, jargon is a very old library. It's about 20 plus years old at this point. It's large and it's pretty big and hard to maintain. And so it also makes decisions for the developer about how it should be used, which limits its ability to, which limits control in certain situations. And it also can be awkward for first-time users when they have to use this. And so we wanted to look into building a Java library which was very easy to maintain, tiny, and also we wanted to publish our Java libraries to Maven Central Repository so that we could be more normal and boring. So what does this mean for jargon? We have officially deprecated jargon. Applications that are relying on it shouldn't be moved. They should plan to migrate to irods4j or into a different library entirely. Yeah. The only thing that jargon is still will receive updates, but those updates will be in support of metalinks because that is the primary application that the consortium maintains and that we will continue to support until we make decisions to go in a different direction. So what does irods4j provide? So as I said, it is hosted on Maven Central Repository, so it is easy to get access to. It provides a low-level API as well as a high-level API. These two interfaces, they mirror the C and C++ interfaces as much as possible. And so what that means is that documentation for the C API is also documentation for the irods4j low-level interface. The keywords and all those things work the same way for irods4j as they do for C. Right now we have support for native authentication and PAM password-based authentication schemes. There's also some options for controlling various socket behavior. And then we also have, as one would expect, SSL, TLS support as well. We do provide implementations for Java 8 and Java 17 too, so they do the same thing. One just uses modern syntax, which is a Java 17 implementation. But for those people who are still locked to Java 8 for now, there is an implementation which you can use. So as I said, the primary design for irods4j is that we wanted to make maintenance very easy, and we wanted to offer as much control that people get in the C and C++ libraries in Java. This is implemented on top of the XML protocol. And that decision is mainly because, it's easy to read XML, and this gives us we don't have to focus on it's not about being as fast as possible at this point. We just want to make sure that the library is correct and that usage is easy. It uses the Jackson JSON library for serialization of packing instructions. And as I said, by the decision to mirror the C API means that we future-proof the library moving forward, because any changes that we make in C can be directly translated to the irods4j library. At the very bottom of this slide, you'll see an example of what this looks like. In the C API, we have two functions called RC connect and RC disconnect. These are modeled just like in irods4j. These are modeled just like in the C and C++ libraries. So everything is here. We also have the same data types as much as possible. And so now we're going to get into some examples for irods4j. So when it comes to connecting to a server, we have all these examples are going to be using the high-level interfaces because they are just easier and they're easier to use for one thing, and they have more control. They have behaviors which reduce the chance of error for users. So the iRODS connection interface wraps an RC communication object, and this allows developers to quickly connect to an iRODS server, do some work, and then have it automatically closed. This is about as close as you can get today with Java having semantics such as destructors and whatnot that you might see in C++. But as you can see in the example, the try block is our control point for making sure that the object that we instantiate is properly disconnected, regardless of exceptions and whatnot. Second example, this is the connection pool. So unlike Jargon, we have a dedicated connection pool, which is modeled after the C++ implementation. You can basically tell it to, hey, I want 10 connections or any number of connections. And then you can specify your, you give it a callback for how to authenticate each connection with the server. And then you can just use just like with anything else, you can use a try with resources block to take a connection from the pool and then use it and then return it back to the pool. And so these things will, right now we have, in this example we use a Lambda to demonstrate authentication, but in the future there will likely be default implementations for PAM password, PAM interactive, and native authentication. So no one will have to write this bit of logic to do authentication moving forward. And the nice thing with this here, which I hadn't talked about, is that since this is modeling the C and C++ interfaces, this means that you get access to things such as RC switch user, which paired up with the connection pool allows people to reuse connections and change the identity associated with those connections, allowing for more performance out of your applications. This is something you can use this to implement logic similar to the HTTP API. This is the same patterns that we use in the iRODS HTTP API today. We provide 2 iterators for iterating over collections, just like the C++ libraries. We have an iRODS collection iterator, and we also have an iRODS recursive collection iterator. These can be swapped out. They are interchangeable. So that means that if you start out with a collection iterator and you just change the type, then you will, to like recursive collection iterator, then it will iterate over sub collections, and you can inspect each entry as you iterate over those things. Yeah, so as you can see in the example, this is pretty easy. You just put it in a for loop and you have access to every entry within that collection. All right. So the next example is about I/O operations. In this example, we use the iRODS data object output stream. And this is a high-level class which is modeling the Java, the expected pattern seen from Java I/O libraries. This can be used to easily write data to a data object or replica. This is built on top of the iRODS data object stream, which is inspired by the dstream library. So all these things, so anything that you see in dstream, you can also do in the iRODS data object stream interface where it makes sense in Java. In this example below, you can see we specify all of the necessary arguments, which are logical path, truncate, append, and then we have a buffer which we use to write to the output stream. And of course, again, we have the try with resources block to handle the automatic closing of the data object, regardless of exceptions, if those are encountered. So it's the same thing with reading data objects. We have a data object input stream, which gives developers a simple and familiar way to write data, to read data to a replica. So got a typo there. This is also built on top of the iRODS data object stream. You have access to all of these different types. Using the input and output streams is going to simplify, reads and writes. But if you need to do reads and writes with the same type at different locations and things, then maybe the data object stream is a better choice. The decision is yours. All right, so now we have, this is an example demonstrating rule execution, which is a bit, it's not necessarily complicated, it's just a bit noisy just because we are dealing with more inputs and outputs. So if you squint your eyes around line 8 through 13, you will notice that all we're doing here is we instantiate a rule arguments object. Line 9 is attaching the rule text that we want to execute against the server. In this case, all we're doing is assigning strings to a name variable and a role variable. And then for our inputs, we don't have any inputs because the strings are already they're already inlined into the rule text that we provided. For the output, we are asking the server to, once you write those values to the variables, we want the server to return that information back to us so that we can use those in our client application. And on line 13, we specify the target rule engine plugin instance, which is something that everybody should always do at this point. This is telling the server which rule engine plugin do we want to execute this code against. With that in place, then we can call the static function iRODS rules.execute rule, passing our rule arguments in our communication object, and then we get a result set back. We get some results back, and then we can extract the information that was provided by the server from it. All of the implementation for irods4j is mainly all function-based. There's no object-oriented, there's limited use of object orientation, and this is intentional because it's just not, that does not align with how iRODS process model actually works. And so moving towards functions, we feel is the right answer, and this has been pretty much proven. We've seen a lot of success with the C and C++ interfaces, so it made sense to, let's see what we can do in Java and see if that same pattern works here. So for future work, we also need to implement PAM Interactive for the irods4j library. This is actually in development and is almost complete. I would say it's about 85% complete. So we can expect to have that in the next release. One of the things that we want to make sure that we wrap up as well is documentation for the public API. We want to automate and expand testing. And then where possible, we want to look into how we can leverage GitHub Actions to help with that automation so that we don't have to put in so much manual effort around getting a release out and make sure that things continue to work for people. So that wraps up the talk. The 020 version is available today. You can use it. And all the things that we're describing in this talk are available and work. Please give it a try. Let us know what report issues and help us make it better. And yeah, that's it. Thank you.
I did not see any questions in the chat, except for noticing that the name looked like other Java projects. So that's not an accident.
Right.
I don't think you had this in our slides. What is our current plan to use this ourselves?
So the plan for this is we are looking at possibly replacing, well, we're looking to replace use of jargon and metalinks with irods4j. That's one use case. One of our interns is actually working on doing that right now and experimenting with that. We are also looking to use the irods4j library to implement things that we're discussing with the imaging working group. And so there's a lot of discussion about how to integrate with Omero and various other projects. And so this is where most of those projects are built on top of Java. So one example is Dataverse. And so this will be, there's an opportunity there to use irods4j as well, and as well as RSpace. And so, yeah, I think this is a good time to have a new library that's fresh and clean and easy to use. and we will continue to hammer out any issues and
Is NFS rods maybe also?
NFS rise as well.
Yeah, okay.
That's true.
Oh, one question. Wait a minute. The people on the internet want to know.
I'm not using them. I'm just curious. As a developer, sometimes I like to write Java code. But can I interchange jargon for irods4j? Like meaning do the functions or do they have the same name? Do they take the same inputs?
No, this is a vastly different API. I would say this is, it does not use many abstractions at all. And so it's all functions. You want to, if you're familiar with the C API, it follows the same naming schemes as the C and C++. So if you look up a function in irods4j, you can also find that same function in the iRODS source code and find all the documentation for it.
All right, thank you. Makes sense.
Yeah, if you have an existing implementation, to swap it out will be real work. But here we are.
I would say the one interesting experiment would be, which I believe is possible, is that jargon can be implemented in terms of irods4j, but irods4j cannot be implemented in terms of jargon. So.
That's good. I like that.
All right.
Yep.
Thank you.